Good afternoon. Am I audible to you guys? Am I audible?
Yes, ma'am.
So in last class, we saw all the different types of queue. So today we will discuss a bit more about circular queue and law operations. So what is a circular queue? Circular queue is just like your normal queue, just that the last node is pointing to the first node of the queue, and therefore it is also known as the circular buffer. Okay. So in case of circular queue, it mainly spontaneous. Circular queue operations. So as you already know, circular queue, you can just point it to the first node. Okay. 5. Okay. So hypothetically, when we insert or delete anything, we can think it as a circular disc, something like this. Okay. So if you arrange them, it will look like three, 4, and 5. So this is your circular cube. Hypothetically, it looks like this, but when see it like normally, it will just look like this. The last node is connected to the first one. So here is also same. The last node is connected to the first one. So what is the main advantage of circular queue? That in normal queue, we have a problem of space. That means even some spaces are empty there. We cannot add anything to the queue because it shows overflow condition. And another way of implementing is that when we add something in queue, whenever we delete something, we always shift it. Okay, if you delete this, we shift again like this. So shifting takes lots of time. So to deal with both the things, we use circular queue. In normal point first what? If you don't shift, even there are empty spaces in front and there are something at the last point, it will not allow you to add any item because it will show overflow condition. Okay, so what happened here? So initially here also front and rear will set to the -1. That means what? It means it is underflow or your stack is empty. Sorry, queue is empty. So you can write it like if front equal to minus 1 and rear equal to minus 1, then it is empty. Okay, or you can say under. So now you want to add something into your circular cube. Okay, whenever you want to add something, you will set the value of front to be 0 and rear to be 0. Okay, so you set the value of front and rear 0 because you want to add something. Okay, so now you see in normal queue what happens whenever we add item, we increase the rear count. Whenever we delete something, we increment the front count. So here you can see both front and rear as a 0. Okay, there is nothing inside here. So whenever you want to add something, you just add a value, then you do rear plus this. Okay, that means rear will be 1 now. Okay, rear will be at location 1. Okay, front is still at 0. It will remain same, just that rear will be at 1. Next, you want to add one more item, example 7. Then you will again do rear plus plus, and now rear value will be at 2. Okay, now you have to add some more item. Keep going on. Next, rear will be at 3. You add more item, rear will be at 4. Then rear will be at 5. Finally, you want to add some more. Here, you added some item. Okay, now your cube is full, and see the location of rear is R5. What is the size of this cube? What is the size of this cube? What's the size? What is the size of this cube? Hello?
-1, ma'am. No, no.
What is the size? It's so simple. How can you not tell the size of the cube? How many elements you can hold here? Rule number 9. What is the size of this cube? Rule number 9. Are you there? তোমালোকে কি এনে এইটো লগাই থৈ দিয়া নেকি তাৰপাছত গায়ব? চাইজটো ক'ব পৰা নাই নে চাই? কিমানটা এলিমেন্ট ধৰি আছে? 20. 20 কেনেকৈ হ'ব পাৰে? Yes, size is 6. How many elements are there? There are only 6 elements. If your index is going from 0 to 5, obviously size is 6, right? How can you not understand such a small thing? Okay, can you tell me how many of you are understanding this subject clearly and how many of you are not understanding this subject at all? একোই বুজি পোৱা নাই ফাৰ্ষ্টৰ পৰা লাষ্টলৈ যি যি শিকাইছে ক্লাছত মন দিয়া নাই আৰু whatever কোনো একো বুজি নোপোৱা কোনোবা আছে মূৰৰ ওপৰেৰে গৈ আছে আৰু ক্লাছ আধা কৰা আধা নকৰা মেক্সিমামটো এদিন এদিন কৰা তাৰপিছত নেক্সট দিনা নাই এটা বেলা থকা নেক্সট বেলা নাথাকা just tell me honestly
Ma'am, stack like বুজি পাইছো কিন্তু বাকিখিনি অলপ কনফিউজন হৈ আছে
কোনখিনি
বাকি কিউৰ খিনি কিউৰ পাৰ্ট
কিউটো যে ষ্টাৰ্ট
stack
কৰিছোহে
block বুজি পাইছো
কোনটো বুজি পাইছা ষ্টেক ব্লক বুজি পাইছা সাৰ্কেল
yes
কিউটো
ma'am
বুজি
stack
পাইছা
like বুজি
নৰ্মেল কিউ বুজি পাইছা
ma'am কনসেপ্টটো বুজি পাইছো কিন্তু কেনেকে কৰে সেইটো অলপ মানে কনফিউজন হৈ আছে
কেনেকুৱা কৰে আই গেছ মই ধুনীয়াকে লাষ্ট লেব ক্লাছত বুজাই দিছো
yes ma'am
ষ্টেকত কি হয় you have only one end okay there is only one end open and you say top so you can add item from one end you can also delete the item from one end okay but what happens in queue it's open from both ends okay you just think about your movie life I guess all of you go for movies টিকেট কাউণ্টাৰত যোৱা টিকেট কাটা তাত কি কৰে ফাৰ্ষ্ট যিজন যাব সিয়ে টিকেটটো পায় যিজন লাষ্ট যাব সি লাষ্টত লাইনত থাকে you just think about any line and just compare with them normal queue we have a front end and we have a rear end so you can add item from the rear end or back side or you can also say tail and you can delete the item from front or you can also say head or you can say just front side is just normal word. So here we maintain 2 pointers, front and rear. And indexes are just same like our array. So if when since you can add only from the back side, that is rear side, you will add one item and you increment the rear. Okay. So what happens obviously initially your queue is empty and you will set your front equal to -1 and rear equal to -1 that means your queue is empty the main condition for any queue f equal to front equal to -1 and rear equal to -1 okay now you want to add something on okay let's say front and rear okay you want to add something what you will do first you will initialize both rear equal to 0 and front equal to 0 at this point that means you are going to add one item okay so you simply add item and you increment rear you increment rear plus plus that means your rear pointer will be here that means r equal to 1 okay next you want to add one more item you add more item and you increment the rear and rear will be now okay you add more item 6 and rear will be at 3. Here is 3. Okay, so this process simply goes on. So the moment you reach the last location, rear will be at this point 4. That means what? Rear equal to, if rear equal to size minus 1, that means it's an overflow condition. Correct? What is the size of this array? 5. You can hold 5 elements in the queue, and your index will start from 0 to 4. So if rear is pointing at 4, that means rear equal to size minus 1, which is an overflow condition. Okay. Now you want to delete something. Whenever you want to delete something, you will delete from the front. Okay. Will delete from the front means what? First you want to delete this number. Now your front will be here. Front equal to 1. Okay. Next you want to delete one more item. Your front will be here. The moment you delete item, you will increment front. It will be front plus plus. This is for delete and this is for add. Add means in case of queue and queue, and delete means dequeue. Okay. So add করিবা, increase rear pointer, delete করিবা, delete front pointer. Okay. So next you want to delete one more item, delete it, and front is at 3. Okay. Now see here there are lots of empty spaces, but you still cannot add anything into the queue. Why? Because R value is still at 4, which is rear minus 1, and it's an overflow condition. Therefore, even if there are some space here, you cannot add any more item because it is showing overflow. Okay, that's the main drawback of your normal queue. So to overcome this problem, circular queue is there. That means it is point back to the 0 again. That means what? If there are empty spaces here, now you can add items here at the previous locations. Okay, so that's what I am showing you guys here. Initially, both front and rear will be minus 1. The moment you want to add something, you just set the value f equal to 0 and r equal to 0. Now rest process is same. You want to add item, rear plus plus to add. Okay, so first it will be r00. Next you want to add one more item. Now r value will be 1. Next you want to add more item, r value will be 2, and so on. So in this way, at the last point, r value will be 5. Okay, now in normal queue, what happens? You cannot add anything right now, right? Because it's completely full. In case of circular queue now, whenever you want to add something, you can delete items now. Okay, you can delete the item and you can add some more items. So the moment here R will be at size minus 1, that means the last position, you can set the value R equal to 0 again. Okay, you can set the value of R to 0 again. Okay, so here when if rear equal to size minus 1, that is at the last position, you can set the value of rear to 0. That's the main advantage. In case of normal queue, you cannot set the value to 0 in normal queue. That's why the problem arises. But in case of circular queue, the moment your queue is full, it is at the last position, you can reset the value of rear to be 0. Okay. Now, suppose you want to add some more item. Okay, your queue is full now. Now you want to add more item. What can you do? It is full, right? So if you want to add more item, here you have a provision that you can delete. Okay, how do you delete? To delete something, you can always increment the front. Correct? You want to delete something now. Now you want to delete. So where is f? F is still at 0. And after inserting this value, r is at 5. Okay. And front is at 0. So now I want to delete something from the queue to add some more. What you will do? What you will do? Simple. You delete the item and set f equal to 1. Increment front plus plus. And you delete this item. Next, you have to delete one more item. Now you set the value 1 here. Okay, now you have more space. Okay, now if you want to delete some more, you can delete this. Now f equal to 2. Okay, delete this item means what? You can completely delete this item. Okay, now you have empty space. Okay, now you can add items here. Now if you want to add items, see here is at 5. So you can just reset the value r to be 0. So here you have reset the value r0. Now same process, you can add item. That means we can add here 30 and you increment the real value again. Here will be 1 now. You want to add some more item. We increment the real value r is equal to. Okay. Now you want to add more. Now see, at this position, we have another condition. Okay. Suppose front is at 2 and rear is at -1. Okay. That means front equal to, for example, 2 and rear is equal to 1. This is another condition. Front is greater than rear, which is another condition for the overflow. Okay. So you can say if front is equal to rear plus 1, then your queue is full. Or you can say over. So now you can see we have two conditions for overflow. What are those? What are the two conditions for overflow? One is real equal to size plus 1, sorry, size minus 1. And other is front equal to rear plus 1. So for both these conditions, your queue will be at overflow condition. Okay. And for empty, it is just simple. It is one condition, front and rear equal to -1. Okay. Only difference is that when your queue is empty here, you can, and r is at the last position, you can always reset the value of r to 0. Then you, if you want to add some more item, you can delete the item and add the new item. Got it? Do you want me to repeat again?
Yes, ma'am. Repeat the overflow conditions.
Overflow conditions. Okay, so first f equal to -1 and r equal to -1 is your empty. I guess this one is clear to all of you, or underflow. Yes, no? Underflow condition.
Yes, ma'am. Underflow is clear.
Now what is the overflow condition? What we do, we add item and increment the here. So we have increment r value here. Now r is at 0 and f is at 0. This location is the first place. That means you are ready to add something. So you add item. Okay. Then you increment r equal to 1. Here plus plus. Okay. Now you want to add more item. Now you r is at 2. Okay. Next you add more. Then can always rear plus plus r3 60, and finally suppose you added something here and 80 and r is at 5. Okay, so if r is at 5, okay, now suppose now your whole queue is well, front is at 0 and r is at 5. Now if you want to delete something, what you do, you delete the item and you increment f, right? You deleted the item and increment front, right? Now you have an empty space here, right? You have an empty space here. Now you want to add some more item. Okay, f is at here now and r is at 5 now. Okay, let's cut this one. You don't get confused. Okay, r is at 5 and f is at -1. Okay, now one space is available here and you want to add something. So now if you want to add something for normal queue, it will not allow you to add. What is the overflow condition? If rear is equal to size -1. This is the underflow. Oh, sorry, this is overflow. Overflow, right? The size is 5 and rear equal to size -1, which is the overflow condition. Now, in case of circular queue, you can reset the value. Okay, for normal case, for normal queue, this is 1. Okay, for circular queue also, it is 1 condition. Okay, now after deleting f is at 1, and now in circular queue, you can reset the value of r, right? So you can reset the value to be 0 again. Okay, and you add the item. Set value is 0 and you can add the item 100. Okay, so now your r is at 0 and f is at 1. So isn't it again, now if you want to add something more, what's the condition now? Can you add something there? Is this condition is satisfying? Rear equal to size -1? No, rear is 0 now. So technically we should be able to add item because this is not satisfying here. R is equal to 0. So this is not equal to size -1. So we should be able to add something into the queue, right? But we cannot. Why? Because your queue is full. So now if you see f is at -1, f is at -1, okay, and r is at 0, that means what? That means what? Front is 1 greater than rear. Front equal to rear plus 1, right? 0 plus 1 equal to 1. So that means what? You can make another condition for overflow. When front equal to r plus 1, then also it will be a overflow condition. So front equal to rear plus 1, then also it's a overflow condition. Got my point now? Now suppose you want to add one more item. What you will do? You have to delete something, right? So in circular queue, in order to add something, and if your queue is already full, you have to delete something. Okay, that's just simple. Now here you want to add some more. So what you will do? You will delete the item and you will increment the counter f equal to 2. Okay? F equal to 2. Now you have an empty space. This condition is not satisfied. F is not greater than R, or you can say F is not, front is not equal to rear plus 1. F is at 2. F is at 2 and rear is equal to 0. That means the condition is not satisfied. It's not overflow condition. That means you can add something. Okay. So you add something again. Okay. And you increment the rear. Rear is equal to 1 now. Okay. Now again same will be same situation is that f equal to 2. After adding the item, rear will be 1. Again, overflow condition 1 is equal to rear plus 1. So, therefore, we have two conditions for overflow. One is normal, rear size minus 1, and other is front equal to rear plus 1. Is this clear now? Okay. So, the advantage of circular queue is that when rear equal to size minus 1, we can always reset the value to 0 in case of circular queue. In normal queue, we cannot. It just fixed size. But yes, in circular queue, if your queue is already full and if you still want to add something, you have to delete an item from the queue. Then only you can add. বুজি পাইছা এতিয়া চবে? বুজি পাইছা চবে? না? Again delete. Now rear will be. If we again delete, then rear will be 1. If you delete item, yes, rear is still at 0. If you want to delete one more item 1, you are only implementing the front. You delete, you increment, you take care of the front point, not rear. So if you want to delete again, this one will be deleted. Front will be at 3. Rear is at 1. That means it's a not overflow condition. You can add one more item. You want to add more one item? You can simply add. F is at 3, R is at 1. So this is not satisfying the condition front equal to rear plus 1. No, we cannot delete from rear. You can delete only from the front in case of circular queue also. So in normal queue and circular queue, you can enqueue thing from rear end and you can delete item from the front end only for both. It will simply follow this rule. You can do that in double-ended queue. This is possible. You can insert or delete from any end, front or rear. But in both normal queue and circular queue, add item from the rear end, you take care of the rear pointer. Want to delete something, you increment front and take care of the front pointer. Okay. Stop sharing. What about others? Pranjal, Arnav, Levin, Pritam, Chintu, Vishal, me. So nice again. Yes, respond to নাই কৰা বুজি পাইছা নাই সঁচা গম পাইছো অনলাইন ক্লাছে চলি আছে নকলেতো বুজি নাপাম 18th পৰাটো অফলাইন ক্লাছ হ'ব তেতিয়া দেখা পাই থাকিম তেতিয়া গম পাম কোনে বুজি পাই আছে কোনে বুজি নাই পোৱা then it is easier for online. That's the problem. I cannot see any of you. So I don't know whether you guys are understanding or not, whether you guys are attending or not. So after puja, it will be easier for all of us. It will be online class. Okay. Okay. This meeting is going to end. Thank you all. দেখা যাব অফলাইনত কিমান ক্লাছ কৰে তাৰপিছত কিছুমানৰ প্ৰব্লেম থাকিব মেম এতিয়া আহিব নোৱাৰো এতিয়া guidelines কিছুমান আছে before coming to campus you have to do RT-PCR and all. People report দিয়াৰ পিছতহে কলেজত এন্ট্ৰি মাৰিব দিব without RT-PCR report তাকো এন্ট্ৰি কৰিব নিদিয়ে so you have to bring the RT-PCR report. Okay. আচ্ছা মাটিত হলে you have to bring RT-PCR. Okay. Okay, thank you all. See you in the next class.